This conveyor belt transports large root vegetables through the processing facility. The belt moves the produce towards the stainless steel machinery for further processing. Inside the equipment, the root vegetables are sorted and prepared for the next stage. High-pressure nozzles spray the produce with water to remove dirt and residue. The produce tumbles forward through the machine, ensuring a thorough wash. The water rinses away impurities, leaving the produce clean and ready for processing. The conveyor moves these muddy vegetables into the cleaning station. Here, high-pressure water jets blast away the dirt and debris. The now cleaned produce continues down the line for further processing. In a modern food processing plant, a high-speed brush scrubs plantains clean. The rotating bristles remove dirt and moisture as the conveyor moves the plantains forward. This automated process clean, consistent product for further manufacturing. Inside the industrial washing machine, high-pressure water jets blast the muddy object. The jets strip away layers of dirt and debris, which wash down the conveyor. The process continues until the object is thoroughly clean. The cleaning process begins as a high-pressure water jet blasts the muddy surface. The powerful spray dislodges thick clumps of mud which fall to the graded floor. The nozzle moves steadily, revealing the clean surface underneath. Sugarcane arrives at the processing plant to be thoroughly cleaned. High-pressure water sprays from overhead nozzles, removing dirt and debris. The water washes over the stalks, loosening impurities that flow away. This prepares the clean stalks for the next stage, extraction. High-pressure water jets thoroughly clean the food item as it rotates slowly. This automated process ensures efficient and hygienic preparation. The item emerges clean and ready for further processing. Here, fresh leeks move steadily along a conveyor belt. The conveyor carries them towards a large processing machine. The machine's internal systems begin to process the leeks. The line continues, ensuring a constant flow of product. In a high-tech sugarcane facility, robotic arms precisely select and process the stalks. The articulated grippers lift carried into the processor, showcasing efficient agricultural automation. The machine begins by feeding the moist, fibrous strands from the left. The strands move steadily toward the central blades. The blades slice the material into thinner, parallel strands. The strands are then wound onto a large roller. These metal rollers rotate at high speed, pulling the stalk through the machine. As the stalk moves, the rollers apply pressure, scraping and flattening its surface. Debris and particles fall away, while the stalk ensures uniformity. Here, the large vegetable is being fed into the rapidly spinning metal rollers. The rollers tear the vegetable apart, producing a continuous stream of shredded material. This efficient process transforms raw produce into a shredded form for further use. The machine's drum rotates, pulling the wet fibers upward from the collection tray. Inside, the material is compressed and sheared, breaking it down into individual strands. The processed fibers fall back into the tray while liquid drains away. The conveyor belt moves the pasta strands steadily through the machine. Overhead sprayers apply water, keeping the product moist and pliable. The camera tinges the pasta as it travels along the belt, a continuous, efficient process. A precise spray nozzle assembly dispenses a uniform coating onto the fibrous material. The material moves steadily from right to left, ensuring even coverage. This automated process is crucial for consistent product quality in food manufacturing. Efficiency and precision are key. Inside this industrial mixer, two large rotating brushes churn a massive batch of shredded material. The brushes dip in and pull the wet mixture upward, creating wave foam. This vigorous action blends the thoroughly for consistent processing. Rows of rolled dough cylinders move along a stainless steel conveyor belt. A white liquid cascades from overhead nozzles, coating the dough to ensure even processing. The dough advances steadily, absorbing the liquid as it moves through the facility. A sheet of dough moves steadily through the machine as the brushes rotate. The brushes apply pressure, creating a textured, ridged pattern on the dough. This process ensures a uniform texture, ready for the next stage of production. High-pressure water jets spray the white substance, washing it as it moves along the machine. The substance is kneaded by rotating rollers, stretching and folding it into a uniform texture, refines the material, preparing it for the next production stage. As they enter the machine, intense steam rises, beginning the cooking process. The belt continues its constant pace, ensuring uniform cooking for large-scale production. This vast industrial facility processes tons of fibrous material, a key step in food production. Material is dried and dyed with steam rising. This ensures a uniform, high-quality result. These uncooked noodles are steadily conveyed on a belt through a heated chamber. Red LED panels above provide targeted heat and light as steam rises from the product. The noodles move continuously, beginning the cooking process in this automated facility. The process begins as the raw material is fed into the rollers. The rollers rotate, compressing and shredding the fibers. The shredded material is then extruded and collected. This automated system ensures a consistent, high-volume output. The raw fibers enter the machine, where spiked rollers begin to open and align them. The process strands emerge, transformed and ready for the next stage of production, which ensures consistent quality and high output in the textile industry. Industrial rollers spin at high speed, drawing in the fibrous material. As the conveyor belt moves steadily rightward, the material is compressed and aligned. This transforms the tangled fibers into a uniform, continuous sheet. Here, raw fibers are meticulously braided and aligned by these stainless steel rollers, transforming them into a strong, continuous material, vital for high-volume textile production. The machine operates continuously, processing the fibrous product at a steady pace. As the material moves through the rollers, it is stretched and guided into uniform sheets. The entire process is automated, ensuring consistent quality and efficiency. The production begins as the noodle strands are steadily pulled downward between two rotating metal rollers. This automated process ensures consistent quality and high output. In the dye vat, a twisted red and white yarn is being processed. The yarn is dipped and rotated, intensifying the bubbling action. This agitation ensures the dye penetrates the fibers evenly. In the heart of the textile mill, the production process is in full swing. A massive curtain of blue yarned metal rollers advancing through the humid, steamy air. This continuous motion transforms raw fibers into the materials of modern manufacturing. This machine processes a continuous flow of red fibrous material. The material moves steadily through the glowing interior. Rollers guide it precisely along the production line, a seamless process powering modern textile manufacturing. In this textile factory, precision machinery operates at high speed. A large spool rotates, winding white fibers into a tight package. Supporting components guide the material, ensuring uniformity. This automated process is replicated across the entire production line. The machine activates, initiating a steady rotation of the red spool. The thread unwinds at a constant speed, guided by the tension arm. Observe the spool's diameter decreasing as the thread is pulled across the frame. In a textile factory, large spools of blue yarn rotate, feeding strands into the machinery. The yarn unwinds at a steady pace, moving from left to right. This process is part of the larger manufacturing workflow. This is a circular knitting machine in operation. Its rotating cylinder pulls blue yarn through hundreds of hooked needles, forming interconnected loops that create a continuous strip of fabric. The machine's precision ensures uniform tension and a consistent weave. This is the knitting machine's needle bed, where the magic of creation begins. The metal hooks move with precision, pulling and looping the red yarn. A new row of knitted fabric steadily emerges from the machine's action. The red knitted fabric advances steadily from left to right, guided by the precision of these industrial rollers. Observe the synchronized gears and cylinders, ensuring uniform tension and flawless output. This is the heart of automated textile production. This is the heart of an industrial knitting machine. Its needles move with precise, rhythmic speed, interlocking yarn to form a continuous fabric. The machine's components work in flawless coordination, producing textiles with incredible efficiency and scale. The laser cutting head positions over the denim fabric, its red beam ready to cut. The head moves right, the beam slicing the fabric precisely. Smoke rises as the laser cuts, showing the power of automation. The clean incision is complete, showcasing modern manufacturing. The automated cutting machine is in position, ready to cut the fabric. The blade spins up and begins to move across the material, slicing with precision. The cut follows the pattern exactly, separating the bra cups cleanly. The process continues, ensuring a consistent, high-quality cut. In a modern factory, robotic arms handle delicate lace bras with precision. The arms pick bras from a pile and place them into organized trays. This automation ensures a seamless process in apparel manufacturing. In a modern factory, robotic arms efficiently sort bras onto a moving conveyor belt. The arm picks a dusty rose bra from this tray. It then places it into the correct bin as the line advances. The automated process begins as the machine's upper assembly descends. It makes contact, applying precise pressure to the components. The assembly retracts, and the conveyor activates to move the parts. This demonstrates the efficiency of modern industrial automation. Here, on the production line, molded bra cups move steadily along the conveyor belt. The smooth, automated process ensures high precision and speed. The background machinery handles assembly, while the cups advance for the next phase. In this automated manufacturing process, robotic assembly arms precisely handle and position delicate components on a moving conveyor belt. The arms grip the components, lift and rotate them into alignment, and place them with continuing the seamless production cycle. The robotic apparatus begins its precision cycle, lowering the upper platforms to engage the garment. A slow, clockwise rotation applies even tension, simulating real-world conditions. The robotic arm's end effector closes, securing the material on the conveyor belt. The arm lifts the material and executes a precise rotation to the right. Using pliers, we firmly attach the hook to the strap. A steady squeeze secures the hook in place. Now, a slight rotation aligns the hook precisely. Finally, we withdraw the tool. The machine's needle moves rapidly, piercing the fabric to create a precise seam. The feed dogs guide the material forward as the presser foot holds it steady. This will ensures consistent quality and speed in textile production. Here, the industrial sewing machine's needle pierces the fabric at a rapid pace. The feed dogs pull the material forward, forming a precise, even seam. This continuous process demonstrates the efficiency of automated textile manufacturing. The laser head is positioned precisely above the lace fabric. The red beam activates, beginning a clean and precise cut. The laser follows a programmed path, cutting at a steady speed. Fabric separates cleanly as the beam completes its path. The industrial sewing machine is now actively stitching the central seam of the beige bra. The needle moves rapidly up and down, piercing the fabric while the presser foot holds it steady, completing the seam with precise, uniform stitches. The sewing machine's needle moves with precision, stitching the black fabric. The operator's hands guide the material, ensuring each buckle is securely attached. This process creates durable seams, essential for a high-quality backpack. The robotic arm positions its gripper to grasp the bra's hook. It pulls the hook back, then aligns it with the eyelet. The hook is inserted and secured, completing the fastening. The arm retracts, leaving the bra securely fastened. These black lace bras are positioned for assembly on the production line. The conveyor belt moves them steadily toward the next station. Here, mechanical arms adjust the straps and ensures precision in every detail. In this automated process, the machine prepares to seal the lingerie. The nozzles lower to apply pressure and heat, forming an airtight seal. After a brief hold, the nozzles retract upward. A mechanical arm then moves the finished package to the side. In this automated warehouse, a robotic arm efficiently handles boxes of apparel. The arm's joints articulate with precision, reaching to grasp a box. It lifts the box, transports it across the facility. Finally, it places the box down, ready for the next task. The automated conveyor system moves boxes efficiently through the warehouse. The diverter plate smoothly guides each box to its designated lane. This seamless process optimizes the flow of goods in the supply chain. Inside this semi-trailer truck, boxes of consumer goods are stacked on pallets ready for transport. A forklift moves in to load another pallet, ensuring maximum efficiency. The operator maneuvers the pallet onto the dock, completing the loading process.